এদিকে আসো। রোগা। এই কই গেল কই গেল? বাবা, এটা কি জিনিস?
Good afternoon.
এখানে তুমি কি রেখেছো? আমার ছোট ছোট ক্লিপ। আমাকে দিও। আমাকে দাও।
This is your course teacher. Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon. How are
Good
you?
afternoon, sir.
I couldn't take your last class. Class on last Monday because there was a problem. I was busy with some others. Anyway, still I can see only 55 students out of more than 75 even. I'm not sure. Why is so small number of people? Why? Is there any reason?
স্যার হয়তো জয়েন করতে টাইম লাগছে, আর 2-3 মিনিটের মধ্যে করে ফেলার কথা সবাই জয়েন।
Is there any class? Was there any class before this one?
জি স্যার ছিল।
Okay. Okay, then fine. So, what was our last topic we discussed in the last class? Previous week, not this week. This week I didn't take any class. We discussed about the quality of irrigation. This was the last topic that we discussed. There are 6 different types of impurities that could make your water unfit to apply for the purpose of irrigation. That your sediment concentration in water, sometimes it may be helpful, sometimes it may be disgraceful. Okay. Total concentration of soluble salts, basically it is not directly calculatable. It is generally measured by taking the measurement of electrical conductivity, because electrical conductivity and salinity is more or less directly proportional to each other. And depending on this, how much electrical conductivity, the water was categorized as 4 types: C1, C2, C3, and C4. Low saline, medium saline, high saline, and very high saline water. 100 to 250, 250 to 750, 750 to 2250 micromoles per centimeter, and more than 2250 micromoles per centimeter is very high saline water, C4 water. And you might know that C4 water is almost discouraged to apply any type of irrigation field. Okay. And there is one more, sodium absorption ratio, that is C, proportion of sodium ions to other cations. Sodium absorption ratio or SAR ratio, depending on the sodium contents. The water was categorized into 4: S1, S2, S3, and S4. Very high sodium water, and the ranges were 0 to 10, 10 to 18, 18 to 26, and more than 26 was the very high sodium water. So we need to convert these species by applying sometimes gypsum or any other way, that is called the leaching processes. By leaching process, we can make unfit water to the fit one. Then we can go for the application of this type of water to the application field. And we are discussing about some toxic elements, and basically boron and selenium were considered as the toxic elements. Boron is very essential for the plant growth, but very high concentration is not suitable for crop production. Okay. But selenium, even a very small amount is available in the water, it will be very injurious for the plant growth. And the other two are the bicarbonate concentration and bacterial concentration. Though bacterial concentration of water is not that much of harmful for the production of the crop, but what you need to do, to cook the food properly so that bacterial contaminated water water applied food should be cooked properly, otherwise it may contaminate your digestive problem. Okay, so these are the six types of contaminations or impurities that can make your water unfit for irrigation purposes, and you need to take care of this. And we discussed in the last class. This would be last class topic. So today I want to start with a new chapter, that is water requirement of the crop. Water requirements of the crops. This is our new chapter to be discussed from today and onwards. Okay. Every crop requires a certain quantity of water after certain fixed interval. There you can see an underline. Certain quantity of water after certain fixed interval. Okay. Throughout its period of crop. No irrigation is required if the rainfall is uniform and sufficient. But you can see in our country, this is a tropical country. A few days back, we were seeing that there is a huge rainfall, but after that, this is basically the starting of the dry period. And you might see from the month of November to even up to the month of March, you might not see any rainfall in our country. In our country, this type of tropical countries. But in England, sometimes you can see it is raining, stopped, once again raining, more or less uniformly. The rains are coming throughout the year, and for that reason, they even do not have that much of bigger irrigation facilities. Okay. So some crops may require irrigation in some parts of the country, depending on the rainfall pattern and rainfall amounts. Some part of the some crop may grow in some part of our country, and same crop may not be grown in some other parts of our country. If I want to give you the example, say compared to Sylhet region, the rainfall amount is very less in Rajshahi or this type of regions. Sometimes it is called the dry regions of our country. So in that part, the crops even may not grow compared to the Sylhet region. There may have some areas where if you want to grow any crop, you definitely need to apply irrigation water. No irrigation water, no production of crop. That type of areas you can find. And some other parts, it will grow, but may not give you the maximum outputs. But it will grow. Somehow it will grow, but it will not give you the good crops or maximum outputs. Depending on these, somewhere no water, no crop. The type of regions are also available. No water, but inferior quality crops are there. That type of areas are also there. Depending on this, the regions are categorized into these two. One is arid region, the area where irrigation is a must for agriculture is called arid region, while the area in which inferior crops can be grown without irrigation is called semi-arid region. It is essential to know that the water requirement of a crop, which is the total quantity of water required from its sowing time up to harvest. Water requirement is not basically same all the time throughout a lifetime of any crop. Naturally, different crops may have different water requirements at different places of the same country. And it also depends on these regions. Regions means climate, variations in the soil types, method of cultivation, effective rain, and so many. The total water required for a crop growth is not uniformly distributed over the entire lifespan of a particular type of crop. The entire lifespan is basically called the crop period. But the total water required of the crop is not uniform. Sometimes you may see a huge quantity of water is required. In same lifespan, sometimes a crop is requiring very high depth of water. Sometimes you may see that very less depth of water is required for the proper nourishment of the crop. So total life span is basically called as the crop period. Or in short, if I want to say you what is crop period, that is the day you are sowing the crop to the time the day you are harvesting the crop. The day you are sowing the crop to the lifespan, the day you are harvesting the crop. So sowing to harvesting, that time frame, that long span of time is called the crop period. Okay, this is the crop period, but you can see there is another term that is called the base period. Actually, the watering stops sometime before harvest. Say you will harvest your crop on 20th November. This is an example. Say you will harvest your crop on 20th November. Today is 11th November, is it? Today is 11th November. So 20th November, you will harvest your crop. But what you did, you stopped applying water to that field on 7th of November. So what is the last day of water application? That is 7th of November. That's why it is saying the watering stops sometime before harvest. And the time duration from the first irrigation. Also, sometimes it happens that you are sowing the crops today, but you are not applying water today. Rather, waiting for 1 or 2 days, then you are applying a huge depth of water into the field. So, sowing day and first watering day, there may have also gap, and also harvesting date and last water application date, there also may have a big gap. So crop period is the sowing day to harvesting day. This is the crop period, and base period is first watering to the field to the last watering to the first watering to the field after sowing, and last watering before harvesting to the field. That time frame, first watering to last watering, that time frame is the base period, and sowing to harvesting is the crop period. So what is your sense? Which one is longer, crop period or base period? What is your sense? Crop period or base period? Are you listening to me?
Crop period.
Definitely crop period. Base period somehow a little bit smaller than crop period. Okay, but though crop period is slightly more than the base period, they do not differ from practical purposes, or if anything is not mentioned in that case, you need to take that crop period and base period is equal. Otherwise, if anything is mentioned, then you need to distinguish this separately. You need to consider these two separately. The next slide, you will see a figure. There you can see the day of sowing, the day of first water application, and first water application is a high depth of water, and in between there is a low depth of water. Water requirement is low, but before harvesting, crops requiring a high depth of water once again, and then stopping of water application, then go for the harvesting. Here it is. Down arrow, first down arrow, second down arrow. This is the second down arrow is the day of sowing of the crop. After that down arrow, there is a gap, very small gap. Then you are applying water with a huge quantity. So this is 100 mm, they are saying. It will be continue for some days, say 10 days or 12 days or 1 week. And after that, you will be applying a low depth of water to the crop field. Crops are gradually growing, vegetative stage. Then when the seeds are coming, that time once again it is requiring a high depth of water. And that will be your last watering that, and it will sustain for a long time. And after that, crop will be almost ripen, and that time there will be no application of water to the irrigation field, to the crop field, and then go for the harvest. So this is the different types of water requirement in a lifespan of a particular type of crop. So this is the paddy. So this is the pattern of water application for getting the good output or good crop yields. This is the pattern of water you need to follow. Otherwise, crops will not be nourished with full-fledged, and it will not give you a very good output of the crop. Okay, this is basically this pattern is followed for the application of water to the paddy field.
স্যার এখানে যে
Yes.
স্যার এখানে যে খালি অংশটা আছে ওই যে ওয়াটার 100 mm এর ওয়াটার যে ডেপটা দেখাইছে ওটার পাশে যে খালি অংশটা আছে স্যার ওটা দিয়ে কি বুঝাইছে ওই যে হারভেস্টের আগে যে লাস্ট ওয়াটারিং করার পরে যে কোনো ওয়াটার দেওয়া হয় না ওই অংশটা বোঝানো হয়েছে এখানে?
Yes. Last 100 mm. After the last 100 mm, are you saying that one?
ইয়েস স্যার,
Yeah.
100 mm এর পরের অংশটা একদম খালি অংশটা যেটা।
After 100 mm, last 100 mm of water application, then gradually that water will be dried up. Okay, that water will be dried up when the crops almost ripen, almost about to be ripened. That time you can see that at the ground you can see no water. On the surface of the ground you can see no water, and it doesn't require any. The moistened soil will supply for the nourishment or for the ripening of the crop. Okay, so third arrow from the left side is the starting of the base period, and up to the time frame you can see the water in the field. That is the base period. And second arrow, from starting of the second arrow to the last crop, you can see last figure of the crop. That is your crop period. Okay.
Yes, sir.
Yeah. So what we discussed up to this time frame is arid region, semi-arid region, no water, no crop is arid region. No water is still less quality of crop is semi-arid region. Water requirements of a crop in total quantity and the way in which crop requires water from the time of its sown to time of its harvesting. As you have seen in the last picture, the way
দিকে তো harvesting
and the
এর
quantity,
আগে
total quantity of water. Water requirements depend also on these factors. I mean the water table, high water table, less water application, ground slope, use ground slope high means high water application, crop, different crop will require different type of water requirement, intensity of irrigation. If you are intending to apply quickly, short period, then less amount of water application. Even method of application of water, places, climate, type of soil, sandy soil, high amount of water requirement, clay soil, less amount of water application because sandy soil is percolating water quickly. Okay, so depending on all these factors, water requirements are depending. And once again, crop period and base period can be summarized. The time period that elapses from the instant of sowing to the instant of harvesting. This is the crop period. And base period, first watering of the crop to the last watering before harvesting. First watering to last watering. Okay, this is the base period. Duty and delta of a crop. These are the two new terms. One is duty, another one is delta. Delta, this is the total depth of water. This is the total depth of water. It may be expressed in hectare meter or simply as the depth or simply meter. From the previous picture, if I want to summarize to explain this one, I can say like this way. Initially, you are applying 100 millimeter. Okay, you saw already 100 millimeter. Then say 30 millimeter, 30 millimeter, 30 millimeter, 30 millimeter for 4 times. So 100 plus 30 plus 30 plus 30 plus 30, 220 millimeter. And lastly, you are applying once again 100 millimeter. So what is the total depth of water applied to the field throughout this lifespan? That is 320 millimeter. That 320 millimeter total depth of water is the delta of that particular crop. Okay. The total quantity of water required by the crop for its full growth may be expressed in hectare meter or simply as depth to which water would stand on the irrigated area. If you consider that you are applying at once at a single time, then that 320 millimeter of water depth you could see in the irrigation field. That total depth of water, total quantity supplied to stand above the surface without percolation and without evaporation. The total amount of depth that you could see in the irrigation field, that is the delta of a particular total depth of water is called the delta. Sometimes there are before discussing about the duty, there I want to inform you two other type of irrigation. That one is paleo irrigation and another one is core watering. Paleo irrigation. This is not related to the crop period or base period. This is even before the crop period and base period. This is in the time frame of plowing. When you are going for plowing or tilting, that time, sometime in dry season, you can see the soil is very hard and very compact. You cannot even plow, you cannot even till. That time you need to make the soils moist, soften. For making this soften or moisten, you need to apply some water, a spray water, either in the format of a spray or whatever it is. You need to apply some water to the field. That very first watering to the field, even before the crop sowing, that first watering is basically called as paleo irrigation. The initial stages before the crop is sown, the land is very dry. In such cases, the soil is moistened with water as it helps in sowing the crops. This is known as the paleo irrigation. And what is core watering? The first maximum watering that you could see, that the first 100 millimeter depth of water, that depth of water after sowing, the maximum watering depth, maximum single watering is called the core watering. Okay, a term core watering is used to describe the watering given to a crop when the plants are still young. It is usually the maximum single watering required, and other waterings are done at usual intervals. Now delta. The total depth of water required to raise a crop over a unit area of land is usually called delta. The total depth of water required to raise a crop over a unit area of land basically called as the delta. That means total depth. So what are the deltas for different types of crops in Indian subcontinent? India region, you could get some predictions about this. For the rice, for different water table conditions, situations, this is 100 to 1500 millimeter. Heavy soils, for medium soils, this is more than that. Even for the very light soils, I mean the sandy soils, it is even more. And this is for upland conditions, wheat are basically requiring very less amount compared to the rice. And it is also showing you the northern India and central India. Early, it's in maize, rainy season, winter season, and summer season. The water requirement for the maize are also different. Cottons, this is more or less 400 to 500 millimeters. Sugarcane, state to state, area to area, it is varying from a particular depth to bigger depths. In Maharashtra, it is almost 3000 millimeters. Compared to Bihar, it is 1400 millimeter. There are two very small problems. Rice is requiring about 10 centimeter depth of water at an average interval of 10 days. You have a crop period of 120 days. So every 10 days, 10 centimeter. In 120 days, 12 times of water you need to apply. Every time 10 centimeter for 12 times, how many centimeters? 1 centimeter per day. That is the delta for rice. And another problem for wheat, this is 140 days of grace period. And every 28 days, the water requirement is 7.5 centimeter. So in 140 days, how many times of water you need to apply? 28 days, that is 5 times, every time 7.5, so in 5 times 37.5 centimeters. Duty, what it is written, forget. You have a canal system. In that canal system, the discharge capacity is 1 cubic. Consider only that. You have a canal system. In that canal system, you have a discharge capacity of 1 cubic. 1 cubic means 1 cubic meter per second. So with that amount of discharge capacity, how many hectares of land you can irrigate, that is your duty. With supply capacity or discharge capacity of 1 cubic, how many hectares of land you can irrigate throughout the entire base period, or whatever you say crop period, no problem. If it is not distinguished, then crop period and base period is same. In entire base period, how many hectares of land you can irrigate, that is your duty if you have a discharge capacity of 1 cubic or 1 meter cube per second. So the area in hectares, in crop period B in days, using 1 cubic meter per second of water. Okay. The factors on which the duty depends are this: type of crop, climate and season, useful rainfall. If there is any useful rainfall, then duty will be increased. If no rainfall, then duty will be definitely decreased. Type of soil, efficiency of cultivation method. There is a relation between these duty and delta. Delta is the total depth of water, in entire base period, and duty is the number of hectares of land if the discharge capacity is 1 cubic. So consider or pretend or assume there be a crop of base period B dash. You have a discharge capacity of a canal system is 1 cubic. So what is the total volume of water applying to that field in B dash, I mean base period, throughout the base period? 1 meter cube in 1 second, in 60 seconds multiplied by 60, in 1 minute, so already multiplied by 60, in 1 hour, once again multiplied by 60, in 1 day, once again multiplied by 24, in base period multiplied by B days. So it is 6,400 into B cubic meter. This is the total volume of water that will be discharged into the field if you have a discharge capacity of 1 cubic. This quantity of water, I mean that volume B, matures how many hectares of land? D hectares of land. What is the relation between meter square and hectare? 10 to the power 4 is the relationship between meter square. 1 hectare is equal to 10 to the power 4 meter square. So 10 to the power 4 D meter square of area. The depth of water applied on this land, volume divided by area. 86,400 B divided by 10 to the power 4 D. Well, this meter. By definition, this water depth of water is called delta. So what is the depth of water applied? The total volume of water you are supplying to this area of land will give you a particular depth. This particular depth is basically called as the, according to the definition, this is the delta. Okay, so delta equals 8.64 b divided by d in meter, or delta equals 864 b divided by d in centimeter. So delta is in centimeter for the last equation, b in days, d in duty. Stop your microphone. Is there sound for
ভাই
us?
আসছিল
Can you please stop your sound?
রিপ্লাই মাল দুইটা লয়েছে 58-40-20 জানি কই মেজাজ গেছে গরম হয় দুইটা এই মাল আপনি যায় না হ্যাঁ দুইটা 58-40-20 একটা এমএসএল কাটা মাল আনছে
Who is this? Are you listening to me going to a fish market or in a construction site? Is it true? Fauzia binte, your microphone is also on.
নো স্যার মাইক্রোফোন তো অফ ছিল।
No, I'm not getting sound from your microphone, but someone, most probably, who is this Tanvir? Tanvir?
Yes, sir. Sir, I was not
Did,
making sound.
did you join to the class right now?
No, sir.
No. Then you still not joined. Are you still not joined to the class?
Yes, I'm joined,
Who was
sir.
making the sound? Who was making the sound? I could listen to the video and I could check. So tell me, who is that one? Going to the fish market or construction area, people are listening to me. Are you doing the class or? Tanvir Hassan Mahadi,
Yes, sir.
did you send any message there as your attendance?
Yes, sir.
You don't need to send any message here. Okay.
Okay, sir. All right.
I could easily get your attendance. Anyway, not go to the fish market or some other where to listen to me. Be inside of your house and listen to me. Be safe from this pandemic situation. Stay home and be safe. Find the delta for the crop when its duty is this hectares per cubic, and basically this one. Yes. This 150 days is equal to this hectares per cubic. Delta equals 120 centimeter. From this equation, you can easily calculate it. What is the picture? Is indicating this one by this one. This is the picture of a canal system, a water source and a canal system. Is it yes or no? This is the picture of a canal system.
Yes, sir.
With a water source, water extraction source. Whenever water is extracted, just after the extraction, the losses of water are started. Losses of water by what type of means? Losses because of the evaporation, losses because of the percolation, losses because of some other reasons. Okay. Just after the extraction, the wastage of water started. Wastages in the way of what? In the way of evaporation, in the form of percolation or depercolation, that is way. So what is your prediction? Can you see this pointer? Can you see this
Yes,
pointer?
sir. Yes, sir.
So at this zone, you will get maximum duty, or at this zone, you will get maximum duty. What is your prediction? What is your idea? You will get maximum duty here, or you will get maximum duty here.
Sir, maybe at the starting point.
Duty will be more. Okay.
Yes, sir.
Is it okay? Are you trying to say that? But I will say that this is reverse. The duty will be maximum here. The amount of water is available at this zone. That total amount of water is entering into the field. No loss. But whenever water is, you are calculating water from here, whenever it is proceeding towards this direction, there will be huge amount of water will be lost because of different reasons. So at this location, you will get less water as compared to this area. So at this zone, the amount of water that you are having, there is no way to once again to have any wastages here. Just after that, it will be entering into the field directly. But if you start calculating from here, that amount of water will not come to this point. When it is coming to this point, a huge amount of water will be lost. So duty will be less here, duty will be more. You are calculating with respect to the amount of water available here. But at this zone, it is moving with a canal system. Okay. So duty will be different at different locations, and at just before the crop field, you will get more duty compared to the water source location. And this duty can be improved. This duty can be improved by taking these two type of measurements. These two measures, if you can take, then the duty of water can be improved. Field preparation and sowing, and handling of irrigation supplies. These two. But what are the importance of this duty? What will be the significance of knowing this duty? If you know the duty first, then you can easily design the efficient canal irrigation system. If you know the duty, then you can easily get what will be the amount of water to be discharged to that field. And depending on that discharge, you can easily come to know what will be the sizes of the carrying canal, what will be the depth, what will be the width, what will be the shape. So Inversely, if you know the crops area required to be irrigated and their duties, you can work out with the discharge required for designing the channel. You can easily calculate what will be the discharge amount, and knowing this discharge, you can easily design the canal. I mean the depth, width, breadth, weighted perimeter, blah blah blah, all these things. Okay, and duty could be improved by taking these two types of measurements. One is precautions in field preparation and sowing, and precautions in handling irrigation supplies. Field preparation and sowing and to be used for cultivation as far as possible should be leveled. If you do not do that, if you do not level your land, somewhere water depth will be high, somewhere water depth will be low. At low water depth zone, crops will not be grown properly. And if the water depth is higher than a requirement, at that zone also what crop will not be grown properly. Field should be properly plowed to the required depth. Improved modern cultivation methods may preferably be adopted. Porous soils should be treated before sowing crops to reduce seepage of the water. Somehow the permeability should be lessened. Many fertilizers should be added to increase water holding capacity of the soil. You can by this way you can increase the duty. Precautions in handling irrigation supplies. The source of irrigation water should be situated within the prescribed limits. Canals carrying irrigation supplies should be lined to reduce seepage and evaporation. You need to line it properly. If you line it, then seepage losses, evaporation losses could be. How evaporation losses could be reduced? If you line, water carrying capacity, water movement capacity will be high. Less obstacle, more water flow. More water flow, less time to evaporate. By that way, evaporation losses will be also reduced. Water courses may preferably be lined to reduce on-field requirement of water. Irrigation supplies should be economically used. Proper control and its distribution. Free flooding system you can avoid. Go for the furrow irrigation method or some other. You know about these techniques and methods. And also in very high scarcity, you can go for the drip irrigation and some other ways so that you can easily increase the duty of a particular amount of water you are having. You can increase the duty of that water. So by this way, you can increase your duty of the limited resources of water you are having. You can get the maximum output. I do not want to. In the next clip, I will discuss the remaining part of the topic. Okay. So I want to stop recording of this class and let me close the class today. Do you want to discuss anything? Tarek Kaisar. Tarek Kaisar. Are you sleeping? Mr. Tarek Kaisar.
Hello.
No sleeping.
Hello.
Then you are definitely discussing with your family members. And for that reason, you are not listening to me. Anyway.
Sir, I have a network issue, sir. Just for 1 second.
Is it?
Yes, sir. I have facing network problem, sir. Sir, my
Oh.
question was that, sir.
Yeah.
Sir, can you please provide the slides, sir, in Google Classroom?
Okay. Okay. I'll upload.
Thank you,
Okay.
sir.
So thank you very much. Hopefully to meet you once again on next Monday.